Assalamu alaikum students. Today our topic is related to self-inductance of a solenoid. Lastly we have read about the self-inductance. Now today we have to read about what? The self-inductance of a solenoid. For that very purpose we consider a solenoid. Solenoid is what? It is simply a coil wound in the form of the helix. It is an insulated copper wire. Let us have this solenoid of length L. Solenoid of length L. And let I is the current flowing through. Current through it is I. Then there will be production of magnetic field inside it, which will be uniform. Then magnetic field inside solenoid, which is a uniform one, uniform, is equal to B is equal to mu 0 times N into I. What's mu 0? Mu 0 is known as, where mu naught is what? Permeability of free space, and I is the current in solenoid. Current in solenoid, and N is number of turns per unit length. Simply you took a solenoid of length L and current through it is I. As the current flows, then there will be production of magnetic field inside it, which will be a uniform. There will be magnetic field around it, but there will be a magnetic field inside it, which will be a uniform, and which is given by B equals to mu naught N I, where mu naught is permeability of free space, N is the number of turns per length, and I is the current. If A is area of cross section of each turn, then a magnetic flux linked with each turn of linked with each turn of solenoid is, that is B into A. As A is the area of cross section of each turn, then magnetic flux linked with each turn is B into A. That is, instead of B we write that is mu naught N I A. So this is the magnetic flux linked with one turn. As there are n turns, the capital N turns, as the small n is the number of turns per unit length. So we will say therefore total magnetic flux linked with whole solenoid, linked with whole solenoid is, what is that? That will be phi equals to, now we are using here whole flux, the flux linked with whole coil, that will be the magnetic flux with one turn, and it should be multiplied by number of turns. So magnetic flux linked with one term. Magnetic flux linked with one term is this much, that is mu naught N I A. And number of turns will be simply N into L, because N is the number of turns per unit length and total length is L. So simply it is how much? mu naught n, that is n square, I a l. This is phi. But also we are having what? But we know, but phi equals to l I. We have to so comparing the two, we'll get l I equals to mu naught n square I a l. The same l here, same l here. This l is flux. It is self-inductance Li. It is Li. Now we are having this I, and I is going to leave. Then simply L comes out to be mu naught n square Al. So thus coefficient of self. This is the coefficient of self-induction of the solenoid, where you can use, instead of n, you can use the term n by L, which implies n, the capital N is equal to n into L. In some expressions you will see, instead of NL you will see the capital N. So this is the expression. This is the expression for self-inductance of a solenoid. So the how we calculated, we first used that the flux linkage is one turn, and then we calculated the total flux linkage with all turns. We know the total flux will be the flux linkage one turn into number of turns. This is the flux linked to one turn into number of turns, that's n into L. And finally what we got? We got phi is equal to mu naught n square IAL, but we know phi is equal to L into I. This is the definition of self inductance. On comparing the two, this I and I is going to leave. Then we get L, the quotient of self inductance, that's mu naught times n square A into L. This is our for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.